This segment is about partitioner, token ring, snitch, and replication. Probably these four topics has to be discussed simultaneously because there is a significant dependency among each other. So let me show you a slide. Let me show you everything here. So the way it works is, and the commonsensical question here is, how would you like to organize your workplace? Are you going to scatter everything all over the place? Let's take, for example, your own home. If you want to find where the printer is, you would rather go to your office, right? The room, your home office. You're not going to look for a printer in the kitchen. And similarly, if you are looking to, get the bread toasted, you're not going to go to your study, right? You're going to find the toaster in the kitchen. So if you really see this whole notion of partitioning and organizing the data based on the needs, you're doing anyways. We do that on a day-to-day basis. Let's take a look at your hard disk. You create a separate folder for your pictures where you store your family photographs. You don't take your family photographs and put it in the same directory where you store your office files or your financial data. That's called partitioning. You partition the data, you group your data, and you store the data that is relevant, related to each other in a specific location. So you know for a fact you can find that data rather quickly by jumping to that location. So now the question is, how does this work in Cassandra? That process is called partitioner. Now I'm not going to walk you through all of these points. Instead, what I'm going to do is I'm going to try and draw this out. Remember, I mentioned that in Cassandra, the more you start thinking about hash maps, the better off you are. And this is the reason why. So what I'm going to draw here is a hash map, and each of these are nothing but the buckets. So let us assume I do hashmap.put and I say key and value. So what will happen? This key will go through a hashing algorithm. What it basically generates is a token or a hash value as such. And this identifies that this is where the data needs to go. So what it does, it takes this value and it puts it in here. So the value comes and sits here. So when I do hashmap.get, and if I say key, this key again goes through the same hashing algorithm, and you go out there and fetch the data from this bucket. And this is essentially O1 performance in terms of the big O notation. Now the whole idea is this particular hash map has a set of buckets. A set of buckets. Let's call it n. N is the number of buckets that this hash map can deal with. If we say n is the number of buckets that this hash map can deal with, doesn't it mean that the number of tokens generated by the hashing algorithm is n? So for instance, if the hashing algorithm can generate tokens from 1 to 100, it can take in an alphanumeric as an input. The hashing algorithm, let's say, generates any number, any token between 1 and 100, which means the number of buckets is therefore 100. Right? This hashing algorithm cannot deal with more than 100 tokens, 100 buckets. So for instance, if I generate or if I have a value called ABC123 hashing algorithm, token is 32, then the 32nd bucket will contain my ABC123. This might be an order number. This might be an employee number. Who cares? That's where my data will reside. Right? That's a hash map. If this is clear, why don't I draw the similar diagram in the context of Cassandra? So suppose indeed I'm sticking with, let's say, these 100 tokens. That's what I'm sticking with. And why don't I draw this in a different color so we can draw the analogy between the hash map and the Cassandra cluster. So I have a single node, N1. And if this is the range of tokens, that means this entire hash map can be represented using just a single node, which means it has the ability to handle 100 tokens, 1 through 100. So if I have an insert statement and I have some way of hashing it, now what am I hashing when I do an insert? Don't worry about that. For now, let's think hash map only, right? I'll explain the concepts of partition key and clustering columns, etc. a little bit later, but not right now. Just imagine you're inserting the data. That data is hashed. And I generate a token 32, 1 to 100, single node. My data will obviously come and sit in N1. No doubts about that. Now, the moment I bootstrap, I add another node. The moment I bootstrap, I add another node, but rest of the nodes I'll come to it a little bit later. So N1 and N2, suppose I have only 2 nodes in my cluster. And given the fact that Cassandra is based on the whole premise that, hey, distribute the data, sprinkle the data across the cluster, divide and rule. If I work backward from that policy, what do you think would be the ideal way in which data should be distributed among these 2 nodes? 50-50. So what I'm going to do? I'm going to say, okay, so N2, when you bootstrapped, you remember all that handshake, etc. After all that handshake is done, N2 says, look, I am here to help you out, N1. I'm here to take on equal load like you, N1. So why don't I split the token range 50-50. So now the new token range becomes 1 through 50 and 51 through 100, which means all the data which N1 was holding between the token range 51 to 100 now has to move from N1 to N2. And that's what happens. I'm currently talking about replication factor equal to 1. I'm getting started slow. I'm going to introduce replication factor greater than 1 here. I'm still in partitioner and I'm slowly getting into the token ring. So therefore, logic says, if I have more nodes, what's going to happen? 4 nodes, range of token. This will now become 1 through 25. This will become 26 to 50. This will become 51 to 75. Oops. And this one is 76 to 100. 25 tokens each. So now you can see that if I have an incoming data which generates a specific token, I know precisely by virtue of this token and this token distribution, token ring, I know ABC123 data has to go to node number 2. Question is, where is this information stored? Because we don't have a master node, we don't have a zookeeper, we don't have a central configuration system in Cassandra. Every node needs to know about this. In other words, N1 is responsible for tokens this, N2 is responsible for token this, which N1 also is aware. N3 is responsible for token range 51 to 75, which N1 is also aware, and so does N2. N4 is responsible for 76 to 100, which is aware, which N1 knows about, N2 knows about, N3 knows about as well. So every node, pay attention to this, not only knows about their own token that they are responsible for, but also the token range of the other replica nodes as well, other nodes as well in the cluster. Don't worry about the word replica nodes, other nodes in the cluster. Make sense? So this information where node N1 is aware of its own token range, this is called as local information. There is a table called system.local. System.local, if you do select star from, you're going to get to know what is the token range that this node is responsible for. And N2 is responsible for 26 to 50, sorry. 51 to 75 is N3, and N4 is responsible for 76 to 100. This information is about peers. System.peers is therefore the table name, which will tell you on N1 what are the peers that N1 has and what are the token ranges they are responsible for. True masterless system. If this is the case with N1, you can similarly visualize what the information is going to be in N2, N3 and N4. Now you tell me, can an application not contact any node and say, hey, here's the data? So what the node has to do? It has to apply the hashing algorithm, figure out the token. So now imagine if for this insert statement, I contacted N4. What do you think it's going to do? Hash token 32. It looks up its system.local. Is it responsible? No. System.peers. Oh yeah, indeed. Looks like 32 token is between 26 and 50. And hey, N2, I got some data for you. Take it. Is this information, sorry, can this processing be done on any node including N2? Absolutely. And if I'm able to, the application, am able to catch hold of any node and put the data, can I not do the reverse? When I say put the data, that's insert. When I want to put the data, that's update. There's also a very interesting term called as upsert. I'm going to talk about that later. And if I want to delete the data, can I delete the data by asking any node? Absolutely. Therefore, can I safely round robin? Yes, I can.